Hello students and welcome back. Today we are tackling a problem on the synthesis of alcohols from alkenes. Pay close attention to the stereochemistry. It's a fundamental concept that appears on almost every exam. Now pause the video and try to solve it yourself. You can check the answer at the end, but if you make a mistake, watch the full explanation to understand why you made the mistake. So, ready to dive in? In alcohols chapter, you might have come across different methods of preparation of alcohols from alkene molecules. For simple alcohol, we simply add water in acidic medium to form the alcohol. For complex alkenes, we can either do Markovnikov's or anti-Markovnikov's addition using specific reagents. Alkenes can also be converted to diols using a dihydroxylation reagents. For the given question, there are two schemes given. In scheme 1, there is a monohydroxylation wherein there is a Markovnikov's addition of water and then there is an anti-Markovnikov's addition of water. In scheme 2, there is a dihydroxylation, but one of the reactions is syn addition of the hydroxyl groups. The other reaction is anti-addition of the hydroxyl groups. And there are different reagents used to carry out the reactions. From the given options, you have to choose the correct reagents required to carry out the conversions. Let's see how to solve this question in detail. What is the difference between these two products here? One is formed by the Markovnikov's addition of water. The other one is formed from the anti-Markovnikov's addition. Although the reaction looks complicated, the reaction is happening only at the double bond. So whether the naphthalene is given or benzene is given here, it doesn't matter. The reactive center is over here. So what is happening from reactant to product here? It is a simple addition of water using Markovnikov's. So whenever there is a Markovnikov's addition, the hydrogen goes to the carbon with more number of hydrogen on the carbon. You see there are two hydrogen. Therefore, hydrogen as proton goes to this carbon. Then what happens to the OH minus? It will go to the carbon with no hydrogens or less hydrogen. So in this case, there are no hydrogens. So it goes here. So H adds here means it is CH3 and the OH goes here as an alcohol. So there is no rearrangement in this case. It is simply obeying the electrophilic addition of water across the double bond. For this, you can simply use water in acidic medium. We can even use mercury acetate. So it's not going to make any difference. Generally, we use mercury acetate when you don't want any rearrangement in the reaction. However, if we use here, it's not going to make any difference. So we can use either this or the mercury acetate followed by the hydrolysis. Therefore, P could be either water acidic medium or mercury acetate. It could be either A, C or D. Not so helpful. Let's check for Q. The Q is anti-Markovnikov's. That means hydrogen goes here, OH goes here. So what do we need here? This is a very specific reaction condition. We use either borane or diborane with hydrogen peroxide in basic medium. So this is very specific. So where do we have it as Q? Q is borane or diborane, right? So it's there in both options C and D. So now what are the correct options we got? C and D, both are correct, but it cannot be this. This is not true, right? Otherwise we'll get the same product here. So A is not the correct option. Now that we know P and Q are the reagents as given in C and D, let's check for S and R. So here both of the products are dihydroxyl products, but one is a cis diol, the other one is a trans diol, because in this both the hydroxyl groups are on the same side. So how do we get this? We get this from syn addition. What do you mean by syn addition? Syn addition means the hydroxyl groups are adding from the same side of the double bond. Generally we use osmium tetroxide or alkaline KMnO4 at lower temperatures. So the KMnO4 is not given. What is given here is osmium tetroxide. Therefore, R is correct. It can be osmium tetroxide. So B could be right, but let's check for S also, right? So for S, what is given? m-CPBA. What is m-CPBA stands for? It is metachloroperbenzoic acid. So remember, whenever we add this m-CPBA, it always does the epoxidation here, and then the water will open up that epoxide ring. So it is always a anti-addition because the epoxide will add here, right, like this, and then the water will attack from the opposite side and it will open up the ring. That means what? We are going to get the trans product as it is anti-elimination. Therefore, this is also correct. Hence, option B is also correct. This is how you have to solve the question based on the reagents. As I told you earlier, don't rewrite the reactions and waste the time. You just have to identify the reagents. First, you read out the reagents and then verify, or you already know what reagents can be used in the reaction. So you write down the reagents and then verify from the statement. So however, it is comfortable for you and you can save some time while doing so. I hope I made this clear, and if you still have any questions on this, ask your queries in the comment section and don't forget to subscribe the channel. Thank you.